Yeah, so hi all, very good evening, and welcome to the third week of problem solving session or live session for artificial intelligence, knowledge representation, and reasoning. So, is my voice clear and is my screen visible? Can you just confirm that once?
Yes, sir.
Okay, thanks. So, we'll wait for a couple of minutes and see if more people join, and then we can begin. Okay, so I guess we can begin, and if people join, they can join as we go through. Also, for today, we are going to discuss some questions related to week 4 of the course. And so today I'm a bit under the weather, so I'll be going a bit slow. So please bear with me. Okay, uh, so without further ado, let's get started with the questions. So this is the question, the first question in front of you guys. So this week we are going to discuss more of first order logic. Last week we had discussed propositional logic, and this week we are going to discuss some questions related to first order logic. So the question tells us first order logic is a language that talks about a domain or the universe of discourse. And we can refer to the elements in the domain using which of the following options. So, taking inputs from last week's session, I'll create a poll and you guys can give in your answers or your feedback in that poll. Okay, just give me a minute. Okay, so I've launched the poll. Okay, I hope you can see the poll. If you go to the bottom right of your Google Meet, you'll see an icon with a small triangle, a small circle, and a small square. If you go there, uh, you'll be able to see the poll option and you can cast your vote over there. Or you can simply write it in the chat as well. Or if you want, you can even unmute yourself and speak up of what you think is the right answer. Okay, so we have one vote for all options. Okay. Any other differing opinions? Remember, we are talking about the domain of first order logic. Okay. Okay, would anyone like to explain their thought process? The person who voted all options would be correct. Why do you think all options would be correct? I am audible, right?
Yes, sir. Yes, sir.
Okay. Okay, so let's consider the options one by one and maybe we'll see why uh, all options are not correct actually. Okay, so let's consider the first option, which is A, maintaining a registry of all the elements. So this doesn't make sense, right? because in logic we are not concerned with making a registry of all the elements, right? So of course this is not the right option. What about B? Okay, how many of you think that B will be the correct option? Just give me a thumbs up or a yes or no in the chat. Okay, I guess we have a shy audience today. Okay, let's discuss the options and hopefully in some time you guys will feel a bit more open. Okay, so we have one option. Thanks, Vanshika. Vanshika says that B, C, and D are the correct answers, and that is in fact correct because we can represent the elements using a constant, right? Also using a variable and also using functions. We cannot represent elements using predicates because predicates in first order logic are basically just the subsets of the domain. Okay, so the correct answer in this case would be B, C, and D. I hope that was clear. If there's any doubt about this question, please let me know. I'll wait for a while.
Sir, can I explain once why the last option is incorrect?
Yeah, sure. So let me just move to this Jamboard. Okay. So suppose this is our domain. Okay, let's call it D, or you could call it U as per universe of discourse. Okay. Suppose we have a predicate over here called man. Okay. And this is basically a subset of this domain. Okay. And this contains now elements like, let's say, Ram. Okay, Ram is a constant symbol over here, or this might contain a variable x, or this might contain a function. Okay, now we can represent these elements using a constant symbol, or using a variable, or using a function. But this predicate itself, man, this is just a subset, right? So we can't represent a particular element using a subset. Do you agree with me?
Oh, yes, sir. Got it. Got it.
Okay. Okay. So if that was clear, let's move on to the next question. Okay. So the second question says that when we define a predicate rich man in our language, L, P, F, and C, okay, and we have a sentence rich man Suresh in the knowledge base that basically what are we trying to assert when we say rich man Suresh? Okay, so which of these options do you think would be correct? Once again, I'll launch a poll. Give me a minute. Okay, I have launched the poll. Okay, we already have one vote for D. Would anyone like to share their thoughts on why D is the correct answer?
So, because the meaning of the predicate's name is doesn't have to do with the name of the predicate. I mean, it can read the rich man doesn't necessarily mean that it's a man or it's rich.
Exactly, yeah. Thanks, Arpati.
Yes,
So,
yes.
yeah, so because in our language or our first order logic, we are not concerned with the actual or language based or English based meaning of the predicates that we are defining. It is just a subset of the domain, and hence D would be the right option. Okay, this was pretty straightforward. Uh, I hope there's no doubt about this. If there is, please let me know. Okay, we have a thumbs up from Somil. Thanks, Somil. We'll move on to the next question. Okay, the third question says an atomic formula in the first order logic is which of the following? Once again, I'll launch another poll. Okay, I have launched the poll. Right, so we have one vote for options A and B. Does everyone agree with that, or are there any differing opinions as well? Okay, so I guess there are no differing opinions, and as we'll see, options A and B are actually the correct answer because an atomic formula has to be a well-formed formula and it has to be the smallest unit that can have a truth value assigned to it. Option C is incorrect because if it has all the logical connectives, it means that it can be further broken down into constituents, right? And that would not mean that it is the smallest unit. So C is not the correct option. And can have only unary connective is also wrong because we know there are atomic formula possible that do not contain a unary connective. Okay, so I hope that was clear. Okay, thanks once again, Somil. Okay, let's move on to the next question. Now, this is concerned with the variable in the first order logic. Okay, so we are given a first order logic formula alpha and we are asked about a variable x in a first order logic formula alpha. Which of the following options do you think would be correct? Anyone? Okay, so I've launched a poll once again for this question as well. You can share your thoughts over there as well. Okay, so we have one vote for A and B. Does everyone agree? Okay, so let's go through the options one by one. And the first option says that it must necessarily be in the scope of a quantifier if alpha is a sentence of first order logic, which is true, right? Because by definition, a sentence in first order logic has to have all the variables that are bound in the or that have a bound scope, right? They are that are in the scope of the quantifier. So if alpha is a sentence, then option A must be correct. And option B is also correct because a variable x can also occur in the scope of more than one quantifier in a sentence of first order logic. Option C is of course incorrect because we are talking about a variable. So a variable can't be a constant. That would just be against the definition of a variable. And of course it can occur more than once in a formula, right? In an atomic formula. So option D is also incorrect. So the correct options are A and B. Okay. Okay, great. So let's move on to the next question. Okay. So question 5 says, let father and coach be function symbols, tall be a relation symbol, sorry about that, and Sneha be a constant symbol of a language PFC, LPFC. Then which of the following are sentences of first order logic? Okay, so I'm not launching a poll for this one because there are too many options. You can just write your options or opinions in the chat, or you can speak up. I'll give you some time to go through the options because there are quite a few of them. Okay, so we have an answer by Somil. Thanks, Somil. We will look at the options. Uh, just for the sake of those who might be a bit lost on or might not remember what a sentence is. So this is a sentence. A formula of LPFC without free variables is a sentence of LPFC. Okay, so I hope this will refresh your memory. And let's go back to the options. Okay, let's see. Of course, the first option is not correct. Can anyone say why? Just based on the definition of sentence that we saw.
So there is a free variable x.
Exactly. Thanks, Somil. So this variable x in the first option can take any value, right? So it's a free variable. So A can't be the correct option. B, on the other hand, is a correct option because it's just it doesn't have any free variable in it. So B is correct. Uh, what about C?
So again, there is a free variable x.
Okay, but x is not occurring anywhere again in the formula, right?
Yeah, that's true.
Yeah. So I think this one has to do something with the definition of a formula itself, right? So if you remember, father is a function symbol, right?
Yes.
Yeah, not a predicate. And if
Right.
we go back to the definition of a function, let me just go back to it for definition of a formula basically. So the set of formula is defined as if alpha is an atomic formula, then it belongs to the set of formulas. If alpha is a formula, then not of alpha is a formula, right? Similarly, if alpha and beta belongs to formula, then and or implication of those are also belong to formula. Okay, but okay, let's go back to the definition of an atomic formula then. Okay, atomic formula. So true and top and bottom are atomic formulas. Okay, if T1 and T2 are two terms, then T1 equals T2. This is a atomic formula, right? And if T1, T2 up to Tn are terms, then predicate of T1, T2 up to Tn is an atomic formula, right? Not a function of. And since here we are told that father is a function symbol, not a predicate or a relation symbol, so option C is also incorrect. Okay, let's talk about option D now. Option D, for all x, tall father Sneha. This actually will be a sentence, right? Because although we have a universal quantifier over there, it's not really appearing anywhere again in the formula, right? So we are not concerned with x being free or bound in this particular case, right? Do you agree with me?
So I'm still confused with the C and D option. Can you explain on the jam for me?
Which one? The C option. The C
Yeah,
option.
C and D, both the options.
Okay, okay. Let me just go back to the class lecture notes. Okay, okay. Let's go back to the basic definitions. Okay. So first, the definition of a term. Okay. So uh, if f is a function, okay, I'm not going through the whole definition. I'm just talking about things that are relevant to us. Okay. So if f is a function, then f of t1, t2, tn, where all these are terms, this is also a term. Okay. Is this much clear?
Yes, sir. Yes, sir.
Okay. Now, so now coming to the definition of atomic formulas, top and bottom are atomic formulas. T1 equals T2, where T1, T2 are terms, is an atomic formula, and T1 up to Tn. So here these might be a function. This might be a function as well, right? Because we know that a function is also a term, right?
Ah, yes.
Yeah. So this will be an atomic formula if P is a n-place predicate symbol, which basically means that P takes n arguments, and P of T1, T2 up to Tn, where each of these are n terms, this whole thing would be an atomic formula. Okay, is this clear?
Okay. Yeah, yeah.
Okay. Now coming to the definition of a formula itself. So for us to have a formula, if alpha is a atomic formula, then it is also a formula, because of course alpha has to be a well-found formula, right? So anything that is an atomic formula will be a formula as well. And then we can do several operations on alpha itself, like not alpha, and then using logical connectives between them to get a formula, right? Now a formula without free variables is a sentence, right?
Yes,
Here
sir.
the C option, in the C option, we are logically connect using a logical and connective. We are connecting tall Sneha. Okay, this is a good. This is a formula because tall is a predicate and Sneha is a constant symbol. But this, on the other hand, is a term, right? Father of Sneha is a term, not a formula.
Yes, sir. Got it.
Yeah, so we can't say that Father Sneha and tall Sneha is a formula. Okay. And since it's not a formula itself, we can't say that it's a sentence.
Sentence. Yeah, got it, sir.
Yeah.
Thank you.
Okay. Okay. So I hope with that option D was also clear.
Ah, yes, sir. It's
Okay.
clear.
Okay, coming to option E now. So there exists X such that tall father X. This is also a sentence, right? Because here, although we have a existential quantifier, the variable is within the scope, right? It's not free, right?
Yes, sir.
Okay, so E is correct. And then F is not correct because again, the same logic. Father is a term, father is a function symbol, not a predicate, right? And then G uh, is a correct option because X is within the scope. Right? So the correct answers are B, D, E, and G. Okay, thanks Somil for the thumbs up. I hope it's clear to others as well. If not, please let me know. I'll just wait for 2 minutes while I'll just have some water. All right. So I hope there are no doubts in this question. Let's move on to the next question. Okay. So here the scenario remains the same. Father and coach are function symbols. Tall is a relational symbol. Sneha is a constant symbol. And we are asked which of the following are sentences of FOL with equality, basically. Okay. So the previous was simply sentences, and these are just sentences with equality. So which of the following options do you think would be correct?
So basically here we have to check if both are terms, right?
Yeah, in a way, you could do that. There might be cases where there is a there is a quantifier and there is a term or there are terms within the scope of those quantifiers. So I'll just let you go through the options. Okay, I'll give you a hint. Uh, Try to think about which of these is not the correct option. Okay, so I'll tell you this much that there is only one option that is incorrect. Try to identify that one. Okay, so Argadeep says option A is incorrect. So Argadeep, would you like to tell why do you think that is incorrect?
Sir, because X is free and there it's not bound.
Exactly, yeah. So we have to remember that this is a sentence, at the end of the day. So it has to maintain the condition of not having any free variable. So because this value in option A, X, this variable X can take any value, so it's free, right? So that's why option A would be incorrect. Whereas all the other options are actually satisfying the conditions of being a sentence and a sentence with equality as well, right? So the correct options would be B, C, D, E, F, and G. I'll just let you go through the options and convince yourselves that all of these are in fact correct. If there's any issue, any doubt, please let me know. Okay, I'll give you a few minutes. Yes, Somil. So in option E, if we didn't have the existential quantifier, we would just have father x equals to coach x, which would again imply that x is a free variable. So yeah, you are right. In that case, E would be an incorrect answer. Okay, let's move on. Uh, by the way, I once again apologize for moving a bit slow today. Uh, as I said in the beginning, I'm a bit under the weather. So yeah, just for this session, bear with me. Hopefully, by the next session, we'll be back to our normal pace again. Okay, let's move on to the next question. Okay, question 7 says that an interpretation I equals to d comma I of LPFC unambiguously determines the truth value of which of the following. Okay, so I'll launch a poll for this one again. Okay, so I've launched the poll. Remember that here you have been asked that you have to unambiguously determine the truth value. Okay, so think about it. If we have to unambiguously determine the truth value, can we afford to have free variables? And can we afford to have bound variables? Think about it, okay, and answer accordingly. Okay, we have one vote for BC and one vote for A and C. Let's wait for some more time and see if there are any more votes coming up. Okay, there's okay. So we had for a while one like extra vote for A and C, but then there was again a vote for B and C. So at the moment they are both standing at 2 and 2 votes. Okay, I'll give you an example. Okay, suppose you had to determine the truth value of let's say something like something that contained a free variable. Okay, now free variable means that it can take any value possible in the domain, right? So can you unambiguously determine the truth value in that case if it can take any possible value? Yeah, we can't, right? That's why we cannot afford to have free variables in our formulas, right? So option A is correct, of course, because formula with terms only from the sets F and C, which is constants and F, right? Formulas basically. Formulas with terms made up of free variables and constant we can't have, right? Because free variables can't be present. Formula with terms made up of bound variables and constant, yes, that we can afford to have. So C is correct. And again, because of free variables, option D is also incorrect, right? So the correct answer is A and C. So I hope that is clear. The people who voted for B and C. I hope that is clear to you as well. If not, please let me know. Okay. Thanks, Moti and Somil as well for the thumbs up. Let's then move on to the next question, which is about unification. Okay. So we are given pairs of clauses. Okay. And we are asked which of the following pairs of clauses are unifiable. Okay. So what do you think about these options? Okay, so we have one answer. Vanshika says B is one of the correct answers, which it could be. Uh, Thanks, Vanshika, for your answer. Would anyone else also like to contribute? There might be more correct options. Just have a look. Think about it this way. When you're trying to unify these pairs of clauses, is there a reasonable or a practical substitution possible when you're trying to unify them? Think about it in those terms. So I would tell you that Vanshika is correct. B is one of the correct options. Okay, and the way you could do that is you could uh, substitute Z1 and Z2, and Anisa is a constant, right? So option B checks out. Option B is correct. Now think about the other options. Okay, maybe D. Okay, okay. In that case, how would you substitute? Uh, we can continue with Z2, Z1 and Z2 as in the earlier case. We can substitute X1 and mother of Anisa, right? I'll just share the unification algorithm with you guys just for a refresher. Remember, the unification algorithm takes two or more formulas and finds the most general unifier of the formulas. Okay. In the list notation of formulas, there are three kinds of elements: lists, constants, and variables. Two constants can only unify or match if they are identical. Okay, so this condition was there in the B option, if you remember, right? So Anisa and Anisa over here, both were constants and identical, so we could unify them. Okay, and Z1 and Z2 are variables, so we can easily unify them. Two lists are unified element by element, building up the substitution as we scan the lists. Okay, and a variable can match another variable or a constant or a list not containing the variable. Okay, So with this in mind, okay, Somil. So I'll briefly go into what unification is. Let me just go through. Okay, let me first tell you what a unifier or a substitution is. Okay, so a substitution theta is a set of variable and value pairs, each denoting the value to be substituted for the variable. Okay, a unifier for two formulas alpha and beta is a substitution that makes two formulas identical basically. Okay, this is basically helpful when we try to do something like a modified modus ponens. So if you remember, or if you had watched this, or for those who might not have watched this, a modified modus ponens is basically when you have something like px implies q of x, okay, and you have p of a. You could do a substitution where theta equals to substitute. This is basically a substitution. You're substituting variable x with a, and now you are deducing q of a, okay, which is basically a combination of modus ponens and universal
Universal instantiation.
yeah, universal instantiation.
Yes, I've seen this lecture, just
Okay,
the unification part.
yeah,
Yes,
so if I come back to the unification algorithm again, and let's look at our options one by one. Okay, so first we have likes, not likes, a variable z1 Anisa, and likes variable z2 mother z2. Okay, if we have to somehow substitute so that these two are identical, we can substitute z1 and z2, right? A variable can be substituted with another variable. Do you agree with me?
yes, sir. Yes,
Yeah. But here we have Anisa, which is a constant, right?
yes,
And
sir.
if you remember from the unification algorithm, two constants can only match or unify if they are identical. In this case, we have Anisa on one hand and mother z2 on the other hand, right? So we can't unify them, right? We could have only unified Anisa with another Anisa. Do you agree?
Yes, sir. Got it.
Yeah. So option A is wrong. We already discussed option B is correct. Let's talk about option D since one of you had said option D is also correct. Again, we can unify Z1 and Z2 and you can replace X1 with mother of Anisa. Okay, that is also valid, right? As per the unification algorithm. A variable can match another variable or a constant or a list not containing the variable itself. These conditions are satisfied over here. There is no violation of the unification algorithm assumptions. So option D is also correct. And option C, we just have variables, right? So we can simply substitute Z1 with Z2 and X1 with mother of Z2. So B, C, D are unifiable while A is not. I hope that was clear. Okay, thanks Somil for the thumbs up. If there's Thanks Orgodeep as well. If there's any doubt, please let me know. I'll wait for 2 minutes for in this question. Okay. Okay, so that's great. If we have no doubts on this question, let's move on to the next question, which we kind of already discussed, but still. So the modified modus ponens rules combines which of the two rules of inference? So I'll quickly just launch a poll for this question as well. Okay, we have a few answers already in the chat. Yeah, so Argadeep and Somil say that it's modus ponens and universal instantiation. Do others also agree? Okay, in that case, I'm not creating a poll because we kind of just discussed it right now only. Okay, we had another thumbs up. That's great. Yeah. So modus ponens and universal instantiation is actually the correct answer. Is there any doubt about this? Any doubts about what is universal instantiation or modus ponens? Uh, okay, just for the sake of any case, like in any case, if there's someone who was still not clear on it, I'll just go through the answer once again. So usually what we would have done if we were given P of question mark X implies Q of question mark X, which basically means that this is a universal quantifier. There has to be a universal quantifier at the left hand side, right? It would have been something like for all X, Px implies Qx, right? Which we are writing as this question mark X. We would have done this universal instantiation, which means that since it is true for all X, it would be true for this constant A as well, and hence we deduce QA, right? So instead of that two-step process, modified modus ponens does that in one step itself. Okay, by using the this concept of unifying or unification, substitution. Okay, I guess this is pretty straightforward. Let's move on to the next question. So this one asks about a Skolem constant. So which of the following options do you think is correct about a Skolem constant? Okay, so I've launched a poll as well. You can share your thoughts over there as well. Again, I'll give you a hint. Multiple options might be correct. Remember the definition of a Scolam constant, how we define or use as a Scolam constant, and then you can answer based on that. Okay, so we have one vote for A and C. Any other option or any other opinions on which of the options could be correct or incorrect? So I'm just sharing the lecture slides, okay, about Scolemization. So when the existential quantifier is not in the scope of any universal quantifier, then the variable that it quantifies is replaced by a Scolam constant. For example, if we had something like exists z, exists z, sorry about that. Yeah, if we had something like exists z and student c, bright c, there exists c, student c, and bright c. Okay, we can Scolamize this as since since z is not in the scope of any universal quantifier, this can be Scolamized as and student sk1, which is where sk1 is a Scolam constant, bright sk1 again where sk1 is a Scolam constant for z, student sk1 and bright sk1. Okay, so this was an example of a Scolam constant. Based on that, okay, so first option is correct because a Scolam constant is like a constant because it maps to a fixed element in the domain D, right? That corresponds to one variable, right? So option A is correct. What about option B? Option B is incorrect, right? Because it's different from a constant of LBFC because it is universally quantified. This is wrong by the definition of a Scolam constant itself, right? If we just go back to the slides, it has to be not in the scope of any universal quantifier, right? So option B has to be incorrect because it is not universally quantified. It is like a variable since the mapping to an element of the domain is not specified, right? We are just replacing z with sk1, right? We don't know what z stands for, we don't know what sk1 stands for. So it's like a variable in that sense. Do you agree? It is also different from a variable, right? Because its value cannot be determined by making an inference. Remember, we are replacing this z with a Scolam constant, right? So in this case, B is the only incorrect options and A, C and D are correct. Okay. Uh, any issues about this particular question? Yeah, so Mil. So what is the purpose of scholemization? That is a good question. So when we talk about these first order logic formulas or sentences or these things, right? We are writing these in our by hand, right? And so it's kind of easy for us to understand. But when we try to implement it, right, using some code, we need to have it in a form that is convenient for us, right? That is convenient for the computer to understand and also for us to code. So this columnization helps in that aspect. That's why we have this concept of columnization, column constant and column functions. Okay. So if you just revisit the lectures from this particular topic, you'll see that Professor Deepak Khemani also gives a brief idea about why we do columnization. So Sayam says that, can you explain option C once again? Sure, I'll do that, Sayam. So option C says that a column constant is like a variable of first order logic since the mapping to an element of the domain is not specified, right? So if we just go back to this example that we had seen, one second, I'll just find that. Yeah, here we had something like exists C and student C, bride C. There exists Z such that student C and bride C. Okay. So we don't know what Z stands for. Z is a variable, and we are replacing Z with another kind of variable, right? It's SK1. Everything else remains the same. We're just doing away with our exist Z, this existential quantifier, right? So in that sense, it is similar to a variable. That is what that sorry, that is what option C is trying to convey. Okay. Okay. So moving on to the next question, which is about a column function. So we saw column constant in the previous question. Now it's about a column function. So it says that a variable, if variable x is substituted with a column function of variable y, it means that, which of the following options do you think? I'll give you a hint. So here we have a lot of options, but only one of them is correct. Okay, so identify the correct one. Okay, so we have one vote for option C over here. So Mil says option C is correct. What about the others? Those who agree, just give me a thumbs up. Write yes or no in the chat. Okay, so Tejas also says option C. That's fine. Mo Sorry, is your name Moti or Rajkumar? Okay, I'm not sure. So yeah, that's not a problem. If you have to leave, that's fine. You can revisit the recording later on. Okay, let's just quickly go over to the lecture slides. And so Skolem constant was, right, initially we saw when the existential quantifier is not in the scope of any universal quantifier, okay, then we can replace it with a Skolem constant. But what if the existential quantifier is in the scope of a universal quantifier, right? So when we have that, when the existential quantifier is in the scope of one or more universal quantifiers, then the existentially quantified variable is a Skolem function of the corresponding universally quantified variables, okay? This is kind of a complicated definition. Let's look at an example. So take the first one, okay? So for all xy, so this is a universal quantifier, okay? Exists z and less than x and z, okay? And less than y and z. So this is basically for all x, for all y, there exists z such that less than xz and less than yz, okay? So when we see over here, so this z over here, right, the z, this is an existential quantifier within the scope of these universal quantifiers x and y, right? So we are replacing this with the Skolem function of the universally quantified variables x and y, okay? So here we have less than variable x, and instead of z we have Skolem 57, which is just some random name sk57, which is a function of x and y, okay? Similarly, in this one we have less than y, and z we are replacing with sk57 function of x and y, okay? So if we go back to the options, so if a variable x is substituted with a Skolem function, that has to mean that x is the existentially quantified variable, right? Because it is being substituted and it is in the scope of y, which is universally quantified. So option C is in fact correct and all the other options are incorrect. Okay, so I'll just let you have a look at the options. Maybe I'll shift the slide once and let you have a look at the examples first. And if there's any doubt, please let me know. I'll wait for a couple of minutes. So Sayam, the recording will be made available by tonight midnight. Okay. I'll try my best to get it uploaded by 10 or 11 itself. But sometimes, due to the recording being almost 2 hours long, it takes some time to process, right? Also, if the video is not of a good quality, then it's not really helpful to the students who are viewing the recordings, right? So, uh, by let's say by 11 or something, I'll try to get the recording uploaded on the channel. Okay. Okay, so that concludes, if there are no more doubts on this question, that concludes our discussion of questions from week 4. Okay, and now we'll be having a look at week 3 questions from the current assignment, which just passed the due date last week. Okay, just for the sake of the people who might be having some confusions about the answers that they may or may not have gotten wrong. Okay, so yeah, let's have a discussion. So the first question was, let the set of atomic sentences in propositional logic be PQRS. Which of the following are sentences in propositional logic? Any doubts about this question? We had discussed a kind of a similar question in the previous live session. Okay, that's great, Somil, if there are no doubts. So basically, the wrong options over here are not presented in the correct format. Okay. So for example, if we take third, the third option over here, it has a not and an and together, right? Which is not a proper format. Similarly for the first one. So the second and the fourth options are correct. What about this one?
Yes, I can explain this one once. Hello.
Yeah, sure, Arkadeep. I'll explain
Yeah.
this one.
Okay. Okay. Okay, sir.
So we are given a knowledge base with four sentences. Okay. We are given not A. We are given B implies C. We are given not D implies E, and not C or E imply A. And we are given a proof. Okay. So let's see how this proof follows basically. So 5 basically comes from this fourth option, right? So if we expand this fourth option, let me just shift to the Jamboard so that it's more clear. So the fourth sentence was not C or E implies A. If we expand this implication, we will have not of not C or E or A, right? Okay, maybe we can proceed in a different way according to the given proof. So this might not be the optimal way. So here they are actually using the first sentence that is given to us, not A, and this implication that is given to us. Okay, so we have this and not A. So using modus tollens, which if you remember was if P implies Q and not of Q, we can derive not of P. Okay, so using these two rules, rule 4 and rule 1, they are deriving not of not C or E. Okay, which is basically what is given to us as the fifth particular instance. Not of not C or E using modus tollens of sentence 1 and 4. Okay, next they are using the De Morgan's law. They are just expanding this one, so they have not of C and not of E, right? Just expanding this outside, doing away with this outside negation, which is what we have as the sixth sentence over here, not of C and not of E. Okay, next what they are doing is simplifying this particular part itself. Not of C is just C, right? So we can write this as C and not E. Okay, just simplifying this not of C, right? And then they are doing and elimination. So C and not E means we can reduce C as well as not E. So they are reducing not E from here, right? So we have 8 as not E, and then they are using uh, modus tollens again for from this eighth sentence, which is not E, and the third sentence, which is not D implies E, right? So we have this implies we have C and not E, and third sentence says not T implies E, and we have not E. So using modus tollens, this implies not of D, right? Which basically means D. So we have found a way to see what are all the processes or what are all the rules of inference that they have used in this proof, and that checks out with the last option. So first they use a modus tollens with sentences 1 and 4, then they do a De Morgan's on the fifth sentence, then they do a not elimination on the sixth one, then they do an and elimination on the seventh one, and they do a modus tollens on 3 and 8 at the end to get D. Okay, that's why fourth option is correct. So was that helpful, or Gurdeep?
Yes, sir. Yes, sir. Thank you.
Okay, okay. So if that was clear, let's move on to the next one. So which of the statements can be derived from the given knowledge base? Okay, so we are given a particular set of facts or knowledge base, which we have S implies not P, S implies Q, R implies P, and R implies not Q. So any doubts about this particular question? Okay, so great. So Milan or Gurdeep, thanks for the thumbs up. This is also pretty straightforward. So I'll just show you one of the options over here. So how we got S implies not R. We as S implies not P, right? So if we have S, assume, then S implies not P. And if we have not P, then we have not P, and R implies P gives us not R, right? So we can say that S implies not R. So similarly, you can proceed to find out about R implies not S as well. Again, pretty straightforward. Let me know if there's any issue. By the time we'll move on to the next question, which is which of the following have logical connectives connecting atomic sentences? Okay, so any doubts about this particular question? Okay, so this is also pretty straightforward. We are asked about which of the following have logical connectives, right? So the first one does not have any logical connective, right? Because it is an atomic sentence itself. The second one is also not having any logical connective because Incy spider can climb the wall is also an atomic sentence. The third one, though, this has a logical connective, right? Because we have an if over here. So if the wall is not dry, then the spider cannot climb the wall, right? So this has some logical connectives like implication in there. So this is the one of the correct options. The next option, it is raining and the wall is wet, also has an and in there, right? So this is also a correct option. Again, the next option, either the sun is shining or the wall is wet. This also has an or over here in the middle, right? So this is also correct option. And the last one is incorrect because it is an atomic sentence. Okay, this is also pretty straightforward. So let's move on to the next question. So this is kind of similar to, based on a similar scenario to as the previous question, and you are given that read the knowledge base carefully, do not assume any extra information, and what are the sentences that can be derived from this knowledge base? Any doubts about this particular question?
In this last option should be correct, so but that's not given in the answer.
Okay, let's look at the last option.
Okay, I can explain also why this is correct.
Okay, yeah, if you want, you can go ahead for sure.
Yeah, in KB it's given that it is raining.
Okay,
You can see. And
uh,
then if it rains, then yeah, it is raining. It's given already.
Okay. Based on this one, you are saying it is raining and the sun is not shining. So we can break it down into it is raining and the sun is not shining. That's why you are saying.
Yeah, it is running, then the wall is wet. It's written in the knowledge base.
Okay, okay, yeah, yeah, it is written, yeah.
So the wall is wet, then in the last option it is written that if the wall is dry. So
Uh-huh.
if the wall is dry means this will be the false. So false implies something will always hold. So that should be the option, I think.
But can we logically derive it using the knowledge base that we have?
Yes, actually, Bhaskaran sir posted it in the
Yeah.
discussion forum, so you can check that.
Okay. Uh, okay. So is the fourth option also, so this is a wrong question, is what you're saying?
No, the question is correct. Just the
Okay.
last option two will be as an answer in the
Okay.
like an example. Yes.
So has Bhaskaran sir said anything about like whether this will be rectified or anything?
Like Bhaskaran sir just asked that check out the proof. So what do you think about that? And so yes, we checked out the proof and it was means we can derive the last option. So
Okay.
nothing after that. See
Okay.
exactly.
Okay. Okay. Let me just have a look at the. Sorry, I just got muted. I was saying that let me just have a look at the response from Bhaskaran sir. Okay. And till then, I'll just wait for a couple of minutes. Okay.
Yeah, sure, sir.
Yeah. So this is the one that you're talking about, right?
Yes, sir.
Okay. Okay. So let's just see. So we have not try or sun from 6. Ah, right, right, right. So we can derive try implies sun from 11. Yeah, in that case, that makes sense. Thanks for pointing that out, Naresh as well as Somil. Yeah, so I hope that is rectified if there was an issue from the NPTEL side.
So would this be a bonus question?
Well, I can't speak on that because I'm not like in touch with the logistics aspect of the assignments.
Okay,
But
okay, no problem.
yeah, but hopefully, if there was an issue, it will be rectified. It has happened before also, so it's not a big deal. Yeah, if there was an issue, it will be rectified. And thanks for pointing that out again. Yeah, Naresh as well as Somil. Okay. Other than that, I hope these options are clear on itself because I see Bhaskaran sir has already shared the solution. So I hope that helps. So let's move on to the next question then. Question 6. So any doubts on this particular question? Okay. Thanks, Somil, again. Yeah, this is also pretty straightforward. So rule 1 is correct because not of P implies P. Rule 2 is correct because P or Q implies P or Q. And rule 6 is correct because, okay, which one is rule 6? P and Q implies P and Q, right? These expansions are correct. The others are wrong because let's take one example. Let's take the third one. not of P or Q. If we expand this, that would be not of P and not of Q. So we can't expand it as an or that is depicted over here, right? So the third one is incorrect. Any other doubts? Okay. So let's move on to the next one. So we are given two tabular expansions and we are asked which of the following is the correct one. Any doubts on this one? Okay. Uh, so I hope there are no doubts with this one as well. Okay. Let's move on to the next one then. Which of the following is a proof by tabular method for the statement that is given over here? Any doubts about this one?
So here we always have to consider the negation part, right?
Yeah, exactly. That's the reason why the second one
Yeah,
is the correct over here.
correct. Yeah,
Yeah,
I got this
because
wrong. I forgot.
yeah, it's kind of a bit tricky. So that's fine. Uh, if we have to prove that the statement is let's say valid, right? Let's say this is alpha. So if we find out there's no model for not alpha, which means alpha is a tautology, we can say, right? And in this case, if we see, uh, it actually does have no model because we have P and not P as well as Q and not Q and R and not R as well, right? So that makes sense. Okay. Okay, let's move on to the next question then. Okay, let alpha be a formula over a set of propositions B, P, Q, R. After expanding not alpha using tabular method, if all the branches are closed, then we just saw an example in the previous question itself. If there are no all branches are closed, then it means that no model, and no model means that not alpha is unsatisfiable, and that means that alpha is a tautology. Right? So this is a pretty straightforward question again. Just let me know if there are any doubts. Okay, this one. Any doubts in this question?
Hello, sir. Hello, sir. Am I audible?
Yeah, Alkadeep. Sorry. Yeah.
Yes, there was a question. Just I think the same question you discussed last week in the revision class, and there you said that the correct options there was just the conjunction is satisfiable and the unsatisfiable, and not the tautology one. But here I saw that it's correct. That's the confusion. Can you please check with that question that you had in the last week
Uh,
doubt session?
sure. I'll just give me a moment. I think there must have been some difference. Let me just check.
Yes. There. Can you please clarify? Yes. Okay, sir. Yes, sir. This one.
Okay. And what do we have over here? Uh-huh. So, okay. Okay, let me do one thing. I'll I'll maybe talk about this with Bhaskar and sir, and I'll get back to you on this, okay?
Okay, sir. Okay, sir.
Because if if this is something we discussed in the last week, then it has to be present in last year's assignment as well, right? Uh, and in that case, only the first two options were correct. So maybe I'll have a discussion with Bhaskar and sir and get back to you on this. Okay. Uh, Other than this question, okay, let's ignore this question for a while. I'll clarify this in the next live session. Okay. Till then, let's discuss the other questions. Any doubts about this particular question? This is pretty straightforward though. Yeah. So this is pretty straightforward because a model for a knowledge base in propositional logic is a list of truth values assigned to all atomic propositions such that all sentences in the knowledge base evaluate to true, which is which is sensible. It makes sense. So that concludes our discussion of questions from the current assignment of week 3 as well. And yeah, so we still have around half an hour left. Uh, if you have any specific doubts, do let me know. We can have a discussion right now. If not, you are free to leave. I'll stick around for around half an hour and I'll see if there are any doubts. And thanks for pointing that issue out, Orgudeep. I'll get that clarified by next week.
Okay, sir. Okay, sir.
Yeah.
So I have a little confusion uh,
Yes.
in the first order level. So, sir,
Sure.
what is a well-formed formula and what is an atomic formula? I'm still confused between them.
So atomic formula has to be a well-formed formula, right? And a well-formed formula is basically a terminology that we use to denote a proper structure of a formula, if I have to say it in a very crude way. Okay.
Okay, okay, sir, got it, got it.
Yeah. If you search about well-formed formula in general, maybe even the Wikipedia page would have a decent amount of information on that. So you could look that up.
Okay, sir. Thank you.
Yeah.
So, is there any group for the course? Because I haven't joined it. So, like you were saying.
Naresh, so I think we have the discussion forum. Have you explored that one? Let me just share my
Like you
screen.
have said that in May. mail or something.
In mail, sorry.
So that information is shared via mail, or is there any separate?
No, no. So I'll just show you over here.
Yes.
So here, if you go to the Swayam portal, no, there is a option called Ask a Question, and if you open it, this is basically it leads to a discussion forum, okay, where you can post your doubts, and Bhaskar and Sir will mostly be addressing the doubts over here. So it looks like this, okay. So for example,
Yeah. Okay.
I think here Bhaskar and Sir has posted the solution for this particular question, right? Like week 3 question 5 that you were talking about.
Yeah. Okay.
So is this what you meant, or we're talking about some other group?
Yeah. For this only I was talking.
Yeah, yeah. So you can access it using that ask a question.
And other.
Yeah.
Yeah. Yeah. And other thing is like the those students who are in already IIT, do they have to register for separate exam, or they will be the automatically included in
Um. So you
for
mean those who are
registration for exam?
so you mean those who are taking the course at IIT Madras? Is that it? So I
Yes.
think
Yes.
so I think if you're taking it as a course as part of your like sorry coursework, then you don't need to register separately for the certificate
Yeah.
exam because you will be having an end semester anyway. But if you want a certificate from NPTEL as well, you can feel free to take that exam as well.
And mid sem will be also there, or only end sem is there?
For that, I suggest you have a look at the course handout on Moodle. Okay, so I think so. You are from
But in that only end sem is.
okay. Uh,
Yeah, I am from MTech CS.
oh, you are from IITM only. Okay, so uh, there are so the
Yes.
handout also mentions quizzes, right? Have you seen that?
Quizzes,
There is there.
quizzes, assignments only, or okay.
Yeah, so I hope I'm not giving you a surprise when I'm saying that you have a quiz tomorrow.
Okay, so I don't.
Okay, okay.
Tomorrow, like in IIT Madras, or there, I don't know exactly.
Yeah, so you should check the Moodle page and the announcement there
Is it?
regularly, right? So just have a look at the Moodle announcements page, and you'll see that there is an announcement about that. So you still have time, so no issues. Yeah,
Okay, okay,
yeah. All the best.
okay. Thanks.
Yeah. So does anyone want to share like how are you finding the course till now? Like, is it meeting your expectations or is it uh, difficult or easier? What do you think? Because when I took the course, it seemed a bit easy in the initial few weeks, but then it seemed a bit difficult in the next few weeks. But ultimately it was a pretty nice experience. So what do you feel till now? Anyone?
Sir, I feel like it's studying, advanced grammar.
Yeah, in a way.
Yeah. But no, sir, the overall the course is very well structured. I feel
Yeah,
enjoying till now.
yeah, that's great. Surekha, you raised a hand. You wanted to say something?
Hello, good evening, sir.
Yeah, hi Surekha. Good evening.
Hi. Yeah, yeah. Now this course, now it is becoming tougher, and this session, it is student oriented, means it is guiding the student how to proceed, and we get courage. Otherwise, we get discouraged. Arey, I'm not getting this, I'm not getting that, like that. So this session is very helpful, and all the material is also very good.
That's. I'm glad to hear that. I'm glad that this
Yeah,
session
yeah.
be of any help
Because
to you.
right, right. Because nowadays our all education is student oriented. Means they help the student to go proceed and further journey. So it is on the same line to discuss doubts and all these things. So this is
Yeah,
very nice. Thank you.
yeah. Thanks for sharing your feedback. I'm glad that you feel that way.
Yeah,
Um,
yeah,
and So I can assure you that as the weeks proceed, although things might seem a bit difficult because they are kind of
yeah,
new, but
yeah.
they will be quite interesting. So I think, for example, in one of the
Right.
weeks you will be learning about something called prologue. So
Yeah, yeah.
I'm not sure if you're familiar with that, but that is quite an interesting topic to look into.
Yeah,
Mm,
and second thing is that now we are returning. I'm working, so we are returning in the evening, 6 to 8 within that time. Now
okay.
we are giving recording also, so that is good because some part we are missing. We are traveling, driving, so it is very nice that some recording in the evening also you will post it at night. So that is very nice.
Yeah. Thanks a lot, Sureka.
Yeah, yeah. Thank you, sir.
So, have any of you done any kind of an implementation or programming with Prolog before this?
Sir, I did one course before this one.
Okay.
But at that time, this type of session was not there. I think 1 or 2 years back.
Yeah,
And
this is something that was started, I think, only
yeah,
maybe
yeah,
last year or before that.
yes,
So,
yes, yes.
yeah.
Mhm.
So I haven't used Prolog. Do you have some examples to show?
Um, so as of now, I don't. Um, I think you'll. So week 5 is out, right?
Yes, yes, sir. Week
So I
5.
think by week 6 you will be getting an introduction to Prolog. It's kind of an interesting language where you can implement these concepts that you have learned over here. Okay.
Okay.
So I am not sure if you know about this problem called the water jug problem. Are you aware of that?
Yes, sir. It was in the AISMPS.
Yeah. It was in
Yes,
AISMPS, right?
yes.
So problems like that, no, water jug problem or the this similar problems like this cannibal and missionary problem, if you remember, uh, things like that you can implement very easily in Prolog. So uh, I think in this course there'll be an introduction to some basic concepts of Prolog and some Yeah, it'll be interesting. Yeah,
Okay, thank you.
yeah. Maybe when we discuss that particular week, I can show you a few programs as well. That
Yes, I told well.
yeah, that can be a bit interesting.
Sir, what is it used for basically? The programming language?
So it is a programming language, right? So it is used for implementing some of the things that are a bit more difficult to implement in other languages. If I have to put it in a very simplified manner. So I have to admit that I am not very experienced with Prolog. I have used it for like a few months, but yeah, it's a new kind of language
Okay, sir. Okay,
in
sir.
the way. So are you familiar with programming with any other languages?
Yes, sir. C, C++, Python.
Yeah,
This.
yeah, yeah. So this will be quite different from the way you implement things in C or Python. So
Okay. Okay.
that's the new speciality of Prolog, you could say. Yeah, thanks a lot for attending, Somil, and of all the others as well, Kudeep, Sureka, and Sunil as well. Yeah, yeah, you're free to leave if you want to leave. I'll just stick around for a few more minutes and see if there are any doubts. Thanks a lot for attending.
Okay, sir. Then I'm also leaving. I have to watch the lectures. I have two videos left,
Sure,
actually.
sure, sure, sure. All the best.
Okay, sir. Okay, sir. Bye.
Okay. Hi, Naga Bhushanam. You just joined. Uh, did you want to discuss something, some doubts from week 4 or previous weeks? Can you hear me?
Yes, it is here, audible.
Okay, okay. If you have any doubts, I'm still around for a few minutes. Feel free to ask.
So nothing is there.
I mean, we discussed the questions from week 4 as well as the questions from the current assignment of week 3. So the slides are already uploaded in the Drive folder. So you can have a look if you want. And the recordings will also be uploaded. So it's not an issue if you joined late.
Okay, okay, okay.
Yeah. Okay, so I guess there are no more doubts, and it doesn't seem like anyone else is joining. So maybe I'll close the session. Uh, so I'll see you next week, and yeah, all the best for the current assignment.